So let's continue. We stopped on the point architecture and technical environment, what it is about. Sometimes you can face with situation that you will try or it will be required from you to combine things that cannot be combined. Sometimes, yes, you can try to do this, but you have to understand that you will have quite significant risks that you will fall with this. Because in most of the cases, it is trade-off between goals, between characteristics, between quality attributes. So you have to choose what is more preferable, what kind of quality attributes has higher priority between each other. Let me try to give you some example. For example, cars. Yeah. So you know that some cars, they are quite fast. They are sporty, but they're not so good on off-road. From another perspective, there are quite good cars. They're good off-roaders, but they're not too fast. And it is not, it's hard to combine these two things in the single product. You can try, but you have to understand that there is a big risk that your result, your car, if you will try to combine both of them and create a good sporty off-roader, that as a result, you will, it's possible that it will be not so good off-roader and it will be not so fast. So keep in mind it. Project life cycle. Previously, one of the oldest approaches, it was waterfall. Later on, when it was noticing that, for example, okay, the designers did their work, the developers did their work, they're just waiting or they don't do nothing, we can give them another kind of task, while, for example, during the testers will be busy with testing the functionality, the designers can start work with the next part, and we get the iterative approach when we go by iterations. And nowadays, in the next level of development and quite modern one, it is agile. Agile, what does it mean? It's the term agile software development refers to a group of software development methodologies. Most you possibly hear about the Scrum, about extreme programming, about Crystal Clear. All these methodologies are all incremental and iterative. One can consider some iterative methodologies as agile. So I believe that you know about it. What is more interesting, it's model-driven development is based on the idea that humans should not be writing the code in programming languages, but they should be creating models of the domain from which code is automatically generated. Sometimes previously I told you that nowadays a lot of things can be generated just only by clicking the mouse on the correct buttons, and it will generate you a huge amount of code if you know what you should do and where to look for it. So humans create the platform independent model, it's PIM. There is platform definition model, it's PDM, and so on. But in most of the cases, whatever kind of approach you will choose of development process, you have to do activities. What kind of activities? It's making a business case for the system. Without the business case, you will not have understanding particular situation. So try to, just for the example, generate 1 or 2 business cases. Understanding the architectural significant requirements. There are different technologies approaches. For example, object-oriented analysis uses use cases and scenarios to work with the requirements. But the key point is to understand the main, to highlight the main significant requirements and concentrate on them. Creating or selecting the architecture. Sometimes so one more time, it doesn't depend what kind of methodology you will use. You will be busy with it, but sometimes it's more easily to select already existing solution than create something from scratch. Documenting and communicating the architectures. Without documentation, your work is just nothing, because no one will know what you achieve. Just imagine the situation. You have key developers on a project. Some of them have significant knowledge about some of the tech or technologies on your project, or logic in your project. What will happen if in some day they will not work with your project anymore? How you will it will be who can replace them if there is no documentation? They are the owners of this knowledge, and this knowledge just only in their head. No one can continue their work, even even if we will talk about them, not this perspective, just from the perspective of science, for example. How do you think why the scientists publish their results and so on? They share their knowledge. If each person will be the owner of this knowledge, nothing will move forward. So it always should be, the science should always base, some results should be always based on already achieved results. So they always should have the ground based on what they can provide next steps. In this particular case, this is the documentation. I will pay attention for it several times because it's quite important. It's quite significant. Because what? Because in the practice, in the real life, a lot of developers, they don't like to do this. It's boring. It's maybe hard but it's important. Still important. Analyzing or evaluating the architecture, yes, but you can do this only if you have the documentation. Without the documentation, you won't be able to do any analyzing or any evaluation process. If you will have it, then based on it, you will have ability to understand how it works right now, give some points or evaluate this architecture, and provide some recommendations in which way you have to move. Implementing and testing the system based on architecture, ensuring that the implementation conforms to the architecture, and so on. From the business context, just keep in mind that business goals, they have influence for quality attributes, and they also have the influence for the architecture and even for the development organization. For the professional, I just quickly will tell you that we have to be quite professional to do this. It's quite simple. No choice. Architecture influence circle. This is also quite big part. I just put here a single image, but maybe we will in future come back. We will see if we will have time, because I just want to mention that for this part, a lot of information is not included on the presentation. So if you will interesting about influence circle, you can try to find additional information about it. There are quite a lot of information. So what we're talking about, you know that you already know that we have different contexts of architecture: business, technical, project, professional. Business, technical, project, they all have influence to the stakeholders, and stakeholders have influence to you as an architect, as a specialist who will be involved to design system, to develop the system. Which kind of influence they have? A lot of significant. For example, one of the key influence, it can be timeline. If you have the limits of time and you have to provide the results, or you have to design the system that will be developed in 3 months, let's say, or 2 months, it's quite significant influence to your decision. So they have influence to your decisions that you will apply. Completely the different situation will be if you don't have any limits. If you can work on the system by years, I think your decisions will be different one. The budget also have the influence. How many developers can be involved? What is the structure of the team? The technical environment. Maybe the customer already use some technical infrastructure, the environment. So it will also influence to your decisions. But from another perspective, as a result of your work, you will also have the influence to all of these things, to the business, to the technical, to the project, to the professional. You can propose your solution based on some technical approaches or infrastructure or technology stack that business will come up and they will start use it. They have to be familiar with this. You can influence for their business processes, how they do this, their business. So maybe you can automate them, maybe you can provide better solutions, better the sequence, the process they already have, and so on. So it's quite a big part. Stakeholders. Yeah. So we switch to the next part, is stakeholder. A stakeholder is anyone who has a stake in the success of the system. It can be the customer, the end user, the developer, the project manager, the maintainers, and even those who market the system. But you have to keep in mind that regular stakeholders have different concerns and interests. Here on the right side on the image, you can see that, for example, we have development, organization, management stakeholders. They want to low cost, keeping people employed. Marketing stakeholders need features, short time to market. They're interesting in short time to market. End user, behavior, performance, security, reliability. Maintenance, modifiability. And another stakeholder, for example, low cost, time, and so on. So each of the stakeholder of the project is interesting and have concern in a different perspective. And your task will be to combine all of this. How do you think? Is it possible to combine all requests in one system that will fulfill for all requirements? Actually, it sounds like, please create the brilliant system that will fulfill everything. It will work fast. The availability will be the best. The performance will be great. It will be quite secured. We need it fast. We don't have budget for it, but we need it for yesterday. And so on and so on and so on. How to deal with all of this? And by the way, it will be your first homework. I will tell about it later. Right now, just a few slides later. So first of all, you have to know your stakeholders. You have to know them. who is involved into the project. Maybe you know someone. If you don't know someone, maybe it's time to know them. And you have to know the interest. It has a significant key role, because maybe the developers will propose you one of the solutions, but they propose you the solutions as from the developer's point of view. It means it can be brilliant from technical point of view, but it will have no sense from the business perspective. It will not bring any benefit, any profit to the business. And your solution will not be needed to anyone. Or so this situation can be different. So here is a table for, as an example, the list of possible stakeholders. It can be analyst, architect, business manager, checker, customer, database administrator, deployer, designer, evaluator. You have to know what they're busy with. So short description will be nice to have. And the interest, what their interest. So for example, for the business magic, understanding the ability of architecture to meet business goals. For the customer, assuring requires functionality and quality will be delivered. Will be delivered in some, and how much it will cost and when it will be delivered. This is the main key point that they will be interesting for. For the database administrator, understanding how data is created, used, and updated, and so forth. So you have here is the continue of this table: implementer, integrator, maintainer, network administrator, project manager, system engineer, tester, users, different roles, different stakeholders. All of them are called stakeholders because all of them have interest into your project, concerns into your project. They are worried about their scope, but in most cases, they interests are contradict between each other. You are not able to combine and to satisfy all of them. If you will try to do this, or you are the brilliant specialist, or be ready to fall. So how to deal with this? In most cases, it's even not possible to combine everything in a single system. As I told you an example with cars. So practical part. Everything before this moment, it was theoretical knowledge. Now you will see a few slides that will have direct connection to your practical tasks that you will have soon. So the steps to stakeholder analysis steps. First, you have to identify potential stakeholders. Try to answer for the next questions. Who has the most influence of this project? Who will be the most impacted by this project? Who control the resources I need? Who has financial stake or interest? Who is important stakeholders? Next, try to prioritize your stakeholders. You can use some visual representation of it. Then create plans for engaging with stakeholders. What are the motivation and priorities for each stakeholder? What are the biggest support or blockers? To identify the stakeholders, you can use different visualization part, and this thing will be required in your homework. You can divide your stakeholders to internal and external. For example, if you will propose to divide them somehow in another way, let's see, try to do this. You can find in internet a lot of different examples. For here are two of them. For example, on the left side, you can mention the project. Then the key stakeholders can be grouped for example, management, team members, owners, customers, and so on. It will be relevant if you have too many stakeholders. If you will have just only 5 stakeholders, 6 stakeholders, and you know them by name, you can just point them here, just by name, John, Nick, and so on, and maybe who they are. Analyst, director, customer, owner, user, and so on. Another one way you can present it in a table view, for example, or something like this, just divided by internal and external. Also, it will be required that you will add some explanation by text, not just only the drawing representation, but also please write at least few sentences that will describe why you identify these stakeholders, why not others. Do you identify all of them? So just few explanation how you will do this. By text, I mean, few sentences. Next, it is, also you can, and it will be required to prepare the table representation of the interest of your stakeholders. You can do it in different ways. Here is one of the examples how you can do this. For example, you can list all your stakeholders, whatever you will have, maybe 10, 20. No need to put all of them with particular details. You're now studying, so the main task is to understand the idea, how it works, and to get a deep understanding and knowledge. Yes, it will be quite good if it will be really practically applied. It can be really practically applied. It just will be the bonus, but you can limit yourself on how big this table it should be. Also, it is relevant for the interest. No need to put too much interest. Try to highlight the most relevant, the key points. Next, it is representation as a grid. After you will identify your stakeholders, try to put them on the next grid. For example, you can use power interest grid. So you can put here your stakeholders, what is the power of each of them, what is the interest of each of the stakeholders. So when you will put here on the grid each of them, you will notice that the persons who will be managed closely, so their interest, their opinion has higher priority, so their concerns about quality attributes, you should pay more attention for them than for others. Let's say, for example, you will identify stakeholders that is, I know, let's say the customer. Well, you will put the customer. The power should be quite big and the interest is quite big. Yeah. Or so if the customer will say that for them it is important that system will be available all the time without any downshifting or so any faults. So you have to concentrate and on your future design on these requirements, more than if, for example, you will have the role of administrator that maybe he has a quite high interest but not big power, and he's interesting to build the system with good automation or something like this. So this is one of the example. There are different, it can be different kind of grids. One of the most popular nowadays is power interest grid, but it is also can be used power influence grid. There is a difference between interest and influence. Interest, it means like interest, how the person is stakeholder is interest. Influence, how the stakeholder can influence to the project. You can also try to have influence impact grid, or I know there are There are others. You can try to find it and also use. No need to create as much as you can. The minimum requirement is just only one power interest grid. It will be enough. If you will be able to prepare another one grids, yeah, it will be nice. Why not? Please show us. At the end of this homework, then you have to combine everything that you did previously in one single matrix, stakeholder engagement matrix. This is one of the most familiar or examples of engagement matrix, but it can look in a different way. You can make it manually, just only by table, and put here different phases into your project. Also, you can represent the for example, instead of risk, you can put the power, or based on previous grids, power or risk, influence, interest. You can point here some estimates by just points, for example, the maximum 5 value, let's say, or 10, how you will decide. The idea is that the person who will read it should understand with which stakeholders they should work more closely and less closely. Which stakeholders will have more influence and should have more influence into your decisions. This is a key idea. Generally, that's all for this part. Let's stop the recording, and you will have the time to questions and clarification.